For years, buying a Google Pixel meant making a very specific deal. You traded hardware stability for software brilliance. You would get an elite camera and incredibly smart features, but you had to accept that your phone might run hot while recording a basic video, or inexplicably drop a 5G call in the middle of a major city. Now, a series of comprehensive leaks surrounding the upcoming Pixel 11 suggest Google is tearing up that old contract. They're moving far beyond routine software patches and executing a complete ground-up hardware redesign. The crucial question is whether rebuilding that internal engine will be enough to make entrenched iOS users actually leave the Apple ecosystem, and equally whether it can pull demanding power users away from the proven hardware reliability of a Samsung Galaxy. Looking at this comparison table, the traditional Pixel compromise is clearly mapped out: stellar cameras on one side, heat and modem issues on the other. But with a brand new processor, deep local AI, and 4 distinct models, that empty Pixel 11 column requires us to ask a hard question. Is Google finally offering a device that makes switching a safe, logical investment? The shift starts at the manufacturing level. After years of relying on Samsung foundries, Google is partnering with TSMC to build their new Tensor G6 chip on a highly efficient 2-nanometer architecture. They are also removing the notoriously inconsistent XNS modems entirely, replacing them with a new 5G modem supplied directly by MediaTek. This scorecard tracks the practical results of those 2 massive supplier changes. Notice the green checkmarks landing on connectivity and thermals. This specific hardware combination points to a phone that will stay cool under heavy loads and hold a solid data connection when you actually need it. But look closely at the raw gaming row. We've tagged this with a yellow warning because the new PowerVR GPU Google is integrating still will not match the top-tier frame rates you would get from an Apple A-series or Snapdragon chip. Google is making a deliberate choice here. They are completely deprioritizing benchmark wars and peak gaming performance, dedicating their silicon entirely to daily efficiency and heavy AI processing. That specific silicon efficiency is required to run Google's next major software push, the deep, system-wide integration of Gemini Nano and the upcoming Gemini Live 2.0. The goal is to establish autonomous AI agents. Instead of simply answering prompts, the phone will execute complex sequences, like cleaning up your notification tray, organizing scattered screenshots, or booking tickets without you needing to guide every single step. By keeping these actions strictly on the device, your personal data never gets sent to an external server. It also means responses are instantaneous, and your battery avoids the heavy drain of constantly pinging the cloud. This chart illustrates the hidden cost of local AI, the hardware tax. Notice the steep jump in required memory. To run these complex models smoothly, the Pixel 11 Pro models are demanding up to 16 gigabytes of RAM, double the industry standard. Securing zero latency speed and total data privacy requires massive local computing power. That drives up the manufacturing cost, meaning you will pay a premium upfront for memory capacity you might only tap into when the AI is working in the background. Beyond the silicon, the camera array is seeing targeted improvements. A new 50-megapixel main sensor and an overhauled telephoto system are being implemented to clean up low-light photography and refine cinematic video blur. Aesthetically, the highly specific temperature sensor from the past generation is gone. In its place, Google is introducing Pixel Glow, an RGB notification light wrapped directly around the rear camera module. However, if you were waiting for a leap in biometric security, you will need to adjust your expectations. Reports indicate that advanced under-display IR face unlock technology is delayed, meaning the device will rely on standard unlocking methods for another cycle. This mapping breaks down exactly how complex the purchasing decision is about to become. You have 4 distinct options: the 6.3-inch base model, the 6.3-inch Pro with an upgraded LTPO display, a larger 6.8-inch Pro XL, and the Pro Fold. Looking at the missing specs highlighted here, the base model cuts costs by stripping away the LTPO display and that critical 16 gigabytes of RAM. Meanwhile, the Fold carries a steep warning as it steps into a highly competitive market against mature, multi-generation folding phones from Samsung and potentially Apple. This lineup fragmentation forces you into a corner. You either save money on the base model and risk bottlenecking those advanced AI features in the future, or you swallow the massive price tag of the Pro tier to guarantee the hardware keeps up with the software. The leaked specs point to a clear conclusion. Google is finished building phones where brilliant software covers for mediocre internals. The Pixel 11 series represents their transition into engineering highly integrated hardware and AI hybrids. This flowchart maps your transition. Pragmatic upgraders, avoiding the 16GB hardware tax, followed this path to the base Pixel 11. Power users wanting a zero-latency autonomous assistant, your path leads to the Pro. For foldable durability, stick to established ecosystems. The smartphone market has moved past Android versus iOS. The real dividing line today is between cloud-dependent software and heavy on-device computing. With the Pixel 11, Google is deciding that true artificial intelligence must live directly in your pocket, and they are finally building the hardware.
Now, nearly every major AI feature on your phone shares the same limitation. When you ask it to summarize a document or edit a photo, your data has to travel to a server farm hundreds of miles away, wait in a processing queue, and bounce back. It requires a constant connection to function. For years, buying a Google Pixel meant accepting a specific trade-off. You got arguably the best camera software and Android experience available, but you had to live with a processor that ran hot, drained the battery on standby, and lagged behind the competition in raw power. Take a look at this quadrant chart comparing the current smartphone landscape. We are plotting raw hardware performance along the bottom against deep localized AI integration up the side. Devices powered by Apple Silicon and top-tier Snapdragon chips sit down here. They have massive physical computing power, but their AI features still largely operate as surface-level apps or rely heavily on the cloud. The current Pixel models occupy this space. Google has built a deeply integrated software ecosystem, but it is physically limited by hardware that struggles to keep up under heavy loads. Based on the latest leaks, the 2026 Pixel 11 aims to fill this empty space. These leaks describe a transition to an architecture designed to solve the tensor compromise at the source. This is a move toward hardware that supports Google's software ambitions rather than holding them back. The root of Google hardware struggle has been its reliance on Samsung's foundries to manufacture the Tensor chips. To fix the thermal and efficiency issues, Google is moving away from that partnership. This comparison table maps out the physical changes coming to the next generation of Google Silicon. First, Google is moving the Tensor G6 chip to TSMC's 2nm process. By physically shrinking the distance between transistors, the chip generates less heat while executing tasks faster. This manufacturing shift allows Google to target the raw performance and thermal efficiency of modern Apple and Snapdragon flagships. Then there's the connectivity problem. Previous Pixels frequently struggled with dropped signals and heavy battery drain because they used Samsung's Exynos modems. To solve this, Google is swapping in a MediaTek 5G modem. This targets the standby battery drain directly, ensuring the phone isn't exhausting its battery just trying to hold on to a cell tower connection. Finally, they are integrating a custom PowerVR GPU. While it may not set benchmark records, it is a deliberate upgrade from their previous graphics units. Securing space on TSMC's 2nm lines and sourcing premium modems is expensive. When a company stops using cheaper in-house manufacturing, the baseline cost of building the device jumps, and that cost is typically passed to the buyer. By investing in these specific components, Google is making a clear calculation. They are prioritizing hardware that no longer bottlenecks their software. To manage those rising costs while pushing high-end hardware, Google is splitting the Pixel 11 into 4 distinct models, each targeting a different type of user. Let's map this out on a spec matrix. The baseline standard Pixel 11 gets a 6.3-inch OLED display, a 120 Hz refresh rate, a 4,840 mAh battery, and a new 50-megapixel camera. But look at the memory allocation for the premium tiers. The RAM reaches 16 gigabytes specifically for the Pro XL, and the Pro Fold models. That 16 gigabytes acts as a dedicated physical buffer. Running complex, localized AI models requires large amounts of active memory. Without this overhead, the operating system would struggle to maintain stability while processing AI tasks. We're also seeing the removal of low-utility hardware. The thermometer sensor on the back of the Pro models is being replaced. Leaks point to a cosmetic RGB lighting ring around the camera called Pixel Glow for notification cues. For those waiting on under-display Face ID, the technology isn't ready for this generation. Google is skipping it for now rather than shipping a compromised security feature. This lineup creates a clear divide. The standard model delivers a traditional phone experience, but if you want the local AI processing Google is building, the Pro tier becomes the requirement. Most AI phones currently on the market rely on software shortcuts. They take your prompt, send it to a cloud server, and display the result. This flowchart shows how Google's new Pixel Sense AI handles a complex request, like booking a flight ticket, using the phone's own tensor processing units. If you ask a hybrid cloud AI to do this, your request leaves the phone, hits an external server, and sends the confirmation back. It introduces latency and requires your personal data to leave the device. On the Pixel 11, the Gemini Nano model runs entirely on the phone. The request goes straight to the physical TPU on the motherboard, executing without an external server connection. This enables AI agents. While a chatbot just provides text, an AI agent can navigate the Android operating system, scanning your screen and clicking through apps to autonomously complete a multi-step task for you. This keeps your data private. Because the processing is local, the system can analyze your personal emails and live screen without that information ever leaving the physical hardware of your phone. However, running these tasks draws significant power. To prevent overheating, the Tensor G6 will have to manage its own thermals by dynamically shifting loads between the main CPU, the new PowerVR GPU, and the onboard TPU. For an AI agent to be useful, you have to grant it extensive permission to access the apps on your device. Local execution is the primary way to make that level of access secure. If you are looking to upgrade, you must choose between buying a refined, mature flagship today or waiting for this architectural shift in 2026. Use this checklist for your priorities. For localized privacy, autonomous AI agents, and premium connectivity without modem issues, wait for the Pixel 11. For immediate value, under-display Face ID, and reliable performance without heavy AI, buy a current flagship now. Google is moving toward premium, expensive hardware because it is the only way to support the local software they are building. The practice of judging a smartphone strictly by its screen resolution or megapixel count is becoming less relevant as hardware standards across the industry stabilize. The new focus is on architecture, specifically which hardware has the physical capacity to run safe and deeply integrated local software. With the Pixel 11, Google is finally pairing its software with a physical chassis capable of running it. This moves the benchmark for the series from cloud-dependent tools to a model of local